This video covers the exploration of aqueous reactions. Using the 9 reagents, you will be mixing 2 reagents in an organized manner on this reaction plastic sheet. Starting in the upper left-hand corner, place the lead 2 nitrate drop in the empty square so that half of the drop is on the white part and the other half is on the black part. This is done so we can see the formation of precipitate on the dark side and any color changes on the white side.
All right. Now the second drop, which is HCl, it's very crucial because all of you needed to understand that you should not contaminate your reagent bottle. So that drop should be directly added to the top of it. All right, you will see immediately a white PPT. It's being generated. So take a stirring rod, stir 3 times one direction, 3 times another direction, and PPT remains. So record this observation on your page 33, and then white PPT is formed.
During the mixing of the chemicals, when you see effervescence, you should record that immediately.
React 1 drop of lead 2 nitrate with 1 drop of sodium hydroxide. All right. So, same thing. Should be very careful with it. Boop. You can see that drop immediately formed white PPT. Same thing. Use a stirring rod before you put it into it, and then you should clean 3, 1 direction, 3 times another direction. Now, see what happens. White PPT disappeared. Now it is a clear, colorless solution. That raises a question. Which observations should we take into our page 33? We take both. PPT first and clear colorless solution second, row by row. So what I meant is we're going to have 1 drop, 1 drop, 1 drop, and 1 drop, 1 drop, 1 drop. Okay, now the second one is carbonate and sodium carbonate, and then we're going to have 1 drop, 1 drop, 1 drop, 1 drop, 1 drop, drop, and 1 drop.
Continue through the remainder of the boxes and record observations after mixing. During the mixing of the 2 different chemicals, you have to observe the 3 visual indicators of a chemical reaction: change in color, formation of a precipitate, and/or formation of effervescence. While some of the reactions may be very fast, some on the other hand may take longer to react. So be patient.
And then next one, copper 2 sulfate, and then which I have 1 drop, 1 drop. Next one, silver nitrate. Then we will have 1 drop, drop. And then next one will be nitric acid.
Once all the columns are filled, we will now fill all the rows with their respective reagents. The first one being HCl.
every one in this column will have one drop, one drop, one drop, one drop, one drop. Now you can see immediately the air bubble still coming up, right? Very good. So now, well, remember, before you do any stir, you must clean your tip. 3 times the same thing, no reaction. 3 times one direction, 3 times another, no reaction. All right, now 3 times, no. All right, this is very interesting. If you're a chemistry student, you don't see something, but is there any reaction or there isn't reaction? We think, all right? Now, blue sky, now it's green. Ah, all right, so hopefully all of you see it. And then clear colorless, now it's white PPT. And the solution, clear colorless, remain clear colorless. All right, very good. So that entire column is done. One drop. Oh, also, all right, have all the bubbles formed. Beautiful. Okay, so now we're going to do exactly the same thing. Stir, stir, clean, clean. Okay, so, all right, nothing happens. Okay, bubbles formed. Okay, 3 times one direction, 3 times another direction. All right, clear colorless solution now seems to do something else for us. So we're going to just leave there, all right? And so now, time, you can see. Okay, same thing with this reaction with HCl. We don't see anything, but is there any reaction? That is the question. All right, very good. So now, all right, so now what I'm going to do is I'm not going to keep explaining. I'm just going to do it, and then you will have the observation. One drop. All right, make sure you record the color as well, not just the PPT, right? Some of the PPT is white, some it's off-white, some it's yellow, some actually is brown, right? So make sure, right? The key is you should clean your stirring rod before each stir, otherwise the contamination is tremendous, and then that is going to really ruin your reaction. All right. And all right, very good. Okay. You can see this is a off-white, but it's actually in the shade of a blue, and then this is no mistake, it's a blue PPT, and then this is also in the shade of a blue, right? It's not a white, and then this is the brown, and also this is very good. All right, and then sodium hydroxide. Beautiful. Mm-hmm. 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 Beautiful. Okay. Next one, last one will be potassium iodide. And then you simply add one drop, one drop, one drop. Okay, this beautiful bright yellow PPT. And okay, barium chromate. Mm-hmm. Mm-hmm. And the last one is a sodium carbonate. Uh-huh. Beautiful. It's what happens. Okay, so now we're going to, very well done.
Your instructor will also discuss a few exceptions to the solubility rules for common ionic compounds in water, which is on page 14. This sheet has now provided us with a database for identifying unknown solutions at the end of the experiment. Your exploration is now complete. Make sure before you leave class, you have filled all the observations in your lab manual.